I'm Tim Kyowski. I'm the site leader here at Zebra's Mississauga product development space. We have a multi-BU space here, the largest of which is mobile computing, which does a variety of products from rugged tablets to rugged handheld scanners to handheld warehouse type scanners, and all the way down to wearable scanner technology, all of which is designed to be able to be used in different industrial applications in multiple verticals, right from transportation and logistics and warehousing to healthcare and retail applications, front of store, back of store. Most of these products are usually designed to create return on investment by improving efficiencies for various work applications, be that manufacturing improvements with wearables being hands-free, so that the other tasks can be done efficiently but accurately, and there's a variety of efficiencies that we aim for improving for our various customers in these verticals. So this here is a back of hand scanner. It has a trigger button off to the side, and the whole purpose here is the end use for these. Whatever the operator is doing, they may be moving and packing boxes, so they need their hands free, but they need to scan each box for verification that it's in the right place, and they need to be able to do that efficiently, both from an accuracy standpoint and also quality. They need to firmly hold the devices, and in other applications it may be fine to hold the device for what they're scanning because it's on shelves, etc. And they may need keyboards to input when labels have been scratched or damaged. So there's various different needs for our end products, and they're always designed with those items in mind.
Here we are again, back to the fact that we are at the R&D facility. Talk about some of the projects that you work on, specifically with the scanner.
Yep.
For example, you showed me, took me to some of your non-destructive labs.
Yes.
Let's talk about the testing. What kind of testing is done on some of these scanners?
Yeah. So these scanners go through very robust testing. We do various drop testing in different angles. We tumble test them, and all of these tests we have correlated to what it sees in the field in the various verticals that it might be used in, and we have a good understanding of how the tests relate to the long life that these live in the field. So we do insertion testing of batteries to make sure that they continuously fit, or testing into chargers, ensuring that the trigger life over a long life in field is always good, because the user needs to have the feedback that they have scanned something. So again, various tests, all purpose built for the different verticals needs, to make sure that we have the most robust product. So we've got an acoustic lab that does testing, to understand if you're using the device for communication, that the speaker is working fine, but also the microphone, so that the person on the other end is working fine. So it simulates the person's head and torso, and we're able to verify that we're meeting good quality, and that the sound levels are good, but also intelligibility of the voices are good, because again, sometimes these items are being used for mission critical communication, and you don't want the person on the other end to hear the wrong thing. So we also have various RF capabilities, and I took you through the RF lab that can test all our cellular capabilities, our Wi-Fi, and multiple capabilities, and understand them for the European market regulations and North American carrier regulations. So again, we test to make sure that we have the most pristine functioning RF connections, because again, the data connection, the scan is only as good as the information that it sends back to the system. So our customers are scanning these items because they are mission critical. We need to make sure that our connectivity is at that same level of criticalness.